Hello, everyone. My name is Dr. Charles T. Bending. Today, I'll be talking about my specialty, underwater archaeology, and how it pertains to human interaction for thousands of years with the natural environment, and what exactly is underwater archaeology and what we've been able to sleuth out looking at things such as shipwrecks. The first thing I wanted to address is for those who may be less familiar, what is underwater archaeology? Well, according to the Encyclopedia of Underwater and Maritime Archaeology, archaeology practiced in a submerged or underwater environment is considered underwater archaeology. For those who have heard of the term before or can think of one of the most popular things about underwater archaeology is often shipwrecks. And what you can see here is two different versions of shipwrecks. On the left-hand side is the remains of a steamship from the late 19th century on the bottom of Lake Huron as part of the Great Lakes system. And here it is laid preserved with natural algae and other types of growth upon it since that period. On the right-hand side, you see most of the intact lower section of a shipwreck. It seems to be lower than the normals than where it currently sits, the land around it. What I mean by that is this is a shipwreck in downtown San Francisco, California. It probably pertained to the gold rush era period where a lot of miners were being brought up from the Panama Canal by ships in the Pacific Ocean. Once arriving there, a lot of these ships were either disused, abandoned, or couldn't be sailed because a lot of people were going to find gold. So what they ended up doing with a lot of these ships was using them to do land reclamation in downtown San Francisco. So anytime you go and walk down in the downtown area and past maybe some new construction area, there might be a shipwreck that was being looked at by archaeologists. So even in an uninundated site, although groundwater has protected and kept the shipwreck intact, underwater archaeologists can actually happen in marsh and land type of areas. Another example of what underwater archaeologists could study is the submerged landscape of originally dry land construction. In this case, what you see in front of you is a Byzantine chapel in Turkey that originally was on dry land until more water accumulated in the lake and had basically inundated the entire area in the site. There's plenty of examples of this along major coastlines due to changes in water, glacial melting, climate change. There's specifically, for example, in the back of my mind is a ancient Greek city off the coast of Greece that has also been inundated and recently studied by archaeologists as another example of land structures now underwater. And finally, a lot of archaeologists trying to understand a little bit more about the peopling of the Americas, the first Native American groups, usually taking place by terrestrial archaeologists, that's land archaeologists, who work on land sites. But more recently, there is a small group of people understanding that some of the sites from these early period are actually inundated underwater. So they've strapped a scuba tank to their own backs and have gone into places such as these two pictures, which are representing of a project in the river networks of northern Florida, and they're finding remains of projectile points such as arrowheads and other types of material, organic material that survived for over thousands of years, 13, 14,000 years ago. For example, on the right-hand side, the diver is holding what looks like a bone. What it actually is the arm or the leg bone of a juvenile mammoth. So underwater archaeology, sometimes or a lot of times people always associate it with looking for shipwrecks, treasure, but underwater archaeology covers a lot of different bases of everything that man has ever been trying to study our history and our past. What is the origins of underwater archaeology if it's something that you may have not heard of? Well, the first underwater archaeological excavation took place in 1960. And so you can imagine that the subdiscipline is only a few decades old, hasn't even reached a whole century. And we'll get into that in a second. But where does this all come from? I mean, it must have had to have been in existence beforehand. Well, depending on what you think about it, how you envision it, it goes back to what I said earlier, that since man has visited the ocean and interacted with its natural world and the environment, has always been curious about what they could find or see underneath. We have plenty of archaeological sites, both on land and underwater, showing remnants of people who fished, who collected sea clams and things. But as civilization marched on and people developed and became seafarers, in the ancient world, there was a lot of shipping and ships going back and forth. But what that also leads to is problems with ships, whether they leaked, they crashed into each other, they were in a fog and got wrecked, or even caught in a storm. And when these things happen, people still went out and tried to salvage what they could off of these wrecks. And depending on how you look at it, we usually call this an antiquarian history, because these are people that were still either trying to retrieve things because they were still could be retrieved and sold as goods still, or as curiosity, as a shipwreck had been left there for decades, and somebody comes along and finds something that's interesting to look at, such as the antiquarians that you think of for the original origin of archaeology, who go out and dig up places like Pompeii or Herculaneum from that type of period. And here you can see this is actually a fresco, a Minoan fresco from Crete in the Mediterranean, in the eastern Mediterranean, showing a diver diving into the water. And throughout antiquity, especially during the Roman period, there was actually a specialized group of individuals that were just, their lives were divers, free diving, and they would salvage what they could from shallow wrecks. In this example is an ancient shipwreck, probably from the Roman period or slightly earlier. And this is what it looks like nowadays on the sea floor. The almond shape it makes is actually the outline still of that ship, even though the wood that created the entire hull no longer exists. And if you were free diving on a ship after a few years, it probably would look like this anyways, even though this image is from now and not from antiquity, because in the warm waters of the Mediterranean, a lot of marine organisms eat wood, and they love that. We've actually had experiences of testing this by taking rebuilding experimental archaeology of what a ship from that period would have been assembled like. And then off the coast of Cyprus, they put it into an underwater park and then left it there. And only after just 3 or 4 years, there was really nothing left of the hull structure, the wooden hull itself, that you could see, that wasn't, buried by a few inches of sand on the bottom. Everything else that was sitting above, in the current, in the water, in the open water, was completely gone. And so divers in the ancient period would go down and retrieve things, such as all the things you see in this image. All these are ceramic cargo containers called amphora. And clay, when it's created into a ceramic, because it's fired at a high temperature, it remains a stable commodity. And nowadays, when you go and try and carry something or ship something, you always ship something in a box or some type of wooden crate. Specifically throughout the medieval period and then also into the early modern period, you would carry a lot of things in barrels. Well, in antiquity, there was more of a market to carry everything in ceramic containers like the amphora that you see here. And if this was a shipwreck that was recently went down, they would hire these divers to go down and retrieve these type of amphora, because they might still be sealed with some type of trade good, or often enough or organic materials that might survive. Jumping a little forward to a later period in the 1st century of the Roman Empire, you have this little place called Lake Nemi. You can see on the right hand a map of Italy, and then on the left hand side is a small excerpt of the location of Rome in relation to the main map, and where Lake Nemi is only a few miles outside the major metropolis. And here, during 37 AD to 41 AD, there was an emperor known as Caligula, who decided in his great wisdom that he wanted to build 2 large barges or large ships that would sit in this small lake for his own consumption. And here is a visual representation of those ships. After Caligula was replaced by a new emperor, it's believed that these ships were either abandoned or even possibly purposely sunk, so there was no remnants of these vessels that was above water to remind the people of Caligula's rule. But they stayed as part of the normal legacy of people who were from that area. And so even though centuries upon centuries and thousands of years have passed since Caligula's rule, the local populace always knew in this freshwater lake that these hulls had survived. So in the 16th century or so, the local ruler and also later Italian Renaissance engineers had tried to retrieve these vessels without any such luck. But in the early 20th century, under Italian's fascist rule of Benito Mussolini, they were able to drain the said lake and retrieve both of the hulls that you can see here. And so this is another version of what we call the antiquarian history of building up to underwater archaeology as it is today, because these are people that are interested in the underwater environment, specifically about shipwrecks in this case. I have to apologize for anyone who might be interested in more about the underwater structures or the early arrival of Native Americans in the Americas. My background is more on shipwrecks, so that's probably what you'll see a lot of in this presentation. But that being said, it still is a founding of trying to get interested in that history that still was encapsulated and preserved under the sea for hundreds of years. Unfortunately, for these two wrecks, due to World War II, as the Germans were retreating from the U.S. Allied forces, marching up through northern Italy, Germans possibly or is assumed that they burned these two ships out of spite. So the museum where they originally housed still exists today, with two 1/5 size replicas to show you what they may have looked like originally, because fortunately they were recorded in a detailed book that was published after the war, but was recorded before the wrecks were burned. So we have that surviving record. But again, this is part of that buildup of the history behind archaeology. And then also, curiously, we go back to Turkey, like I mentioned earlier, for that Byzantine church. But in this case, rather than looking at an interior lake, I would like to ask you to look more specifically along the southern coastline. Turkey itself is a higher elevation country with lots of mountains, but they also have a very craggy and rocky coast. And it's been home for hundreds upon hundreds and thousands of years of sponge divers. And when these gentlemen wear these hard hat dive suits, because this is what they were using this period to look for sponges in order to sell them to tourists or to the local populace, they would always come across every so often that shipwreck I showed you earlier, full of amphora, and either look at it, maybe retrieve something from it. And this literally brought a lot of people and interested individuals to visit Turkey, visit this coastline, to figure out, to locate ancient shipwrecks. And eventually this led to one gentleman in particular. Oh, excuse me. Before we get to that, the thing about the sponge diving is you can see here, we talked about hard hat individuals going down using some type of air pump on the boat in order to walk around. Well, eventually, in order to do the more modern underwater archaeology, there had to be some type of more freeing apparatus in order to do that. And you see these two gentlemen right here, and in the 1940s, Jacques Cousteau, who was a famous explorer of the undersea and appreciating of the natural environment, but also was curious about archaeology under the sea, and Emile Gagnon came together and invented what's now called the scuba tank, or the scuba diving. And for those who may not be as aware, scuba itself is an acronym. It means self-contained underwater breathing apparatus. So whenever you see reading about scuba diving or anything like that, you may see it in capital letters instead of lowercase, because it's an acronym. What you can see in the bottom left-hand side is an early example of what a scuba diving tank would look like, with a tank strapped to your back, and then a double hose that goes around, and then where number 2 is, that would be where your mouth goes. So between the sponge divers in Turkey finding shipwrecks every so often and reporting them to locals and other interested people on the shore, and Jacques Cousteau and Emile Gagnon inventing the scuba diving apparatus so that people could dive deeper and be more free and unattached to a boat necessarily for their air, it eventually led to the founding of underwater archaeology as we know it today. The first real underwater dive project was led by this gentleman named Dr. George F. Bass. Off the coast of Cape Caledonia, you can see here in this image of southwestern Turkey. When Jacques Cousteau and Emile Gagnon invented the scuba diving tank, they themselves originally went out and started investigating shipwrecks that were off the coast of France. And a few individuals who were on those projects eventually migrated to work with Dr. Bass on his first project. Why we still consider the Cape Caledonia shipwreck as the original founding type of thing is because before this, when people were diving, it was always a diver who was a professional diver who went down, but he had no training in actual archaeology. He or she was a diver who was just basically informed on the surface by an archaeologist who they themselves weren't necessarily a diver, would tell them what to do, or would wait for them to go down, find something interesting, and then bring it up for them to study and look at and bring back to shore and do more analysis on. Dr. Bass is one of the first archaeologists to basically learn to scuba dive himself, along with an entire crew of individuals that went with him, and then go down and be archaeologist first and scuba diver second. He still worked with professional scuba divers alongside him on this project, those that gained experience working with the French on their earlier projects, but he was truly the first archaeologist who was down there making it a more rigorous standard that you would expect on an archaeological dig on land. Here you can see what we call the site plan for the Cape Caledonia wreck. In this case, the shipwreck hit some shallow shoals, breaking the lower half of the hull, letting water quickly go in, and then the ship quickly sank. But it was such a rocky environment, and again, we talked earlier about the warm waters of the Mediterranean, that a lot of the wood had not survived to the hull structure, but the cargo was still intact. And all these little things that might, for some people, might look like pizza pockets or some type of other type of sleeve type of thing, those are actually copper ingots, basically. The way that they shaped them, they kind of represent like a hide, if you will, that was stretched out, and that they thought that was a preferred way to pour the molten copper out in order to make it transferable and carryable on ships and other things, and maybe even use the extensions as handles to carry them on and off of ships type thing. And this copper would be mixed with bronze, which was also found along with this to create bronze during the Bronze period, from where the shipwreck is from, is the Bronze Age. And here you can see some of that early investigations with the scuba tanks and looking at, again, those bronze ingots as they were stacked originally when the ship went down type thing, where they laid for thousands of years until the archaeologists came along. And so after Dr. Bass did this, he basically founded like this new subdiscipline, and it's become, more successful every year ever since. There's more and more people getting into it. There's more and more sites that are being uncovered and found. There's more people that are finding, more places are being inundated due to climate change. So there will be more under archaeology in the future, no doubt about that. But this gives you a little bit of a background of where it, originally stemmed from, and where it kind of the founding of a scientific discipline, if you will. Even though, as I said before, we've been always curious about under the sea and the natural world, and we've always gone there to see what might be there. Moving forward, if you go down there to find shipwrecks, not every single place has a wonderful collection of professional divers looking for sponges like off the coast of Turkey to tell you about neat wrecks that they may have uncovered or found. Nowadays, how do we as underwater archaeologists look and find places and sites underwater if you don't have that beautiful clear viz of the Mediterranean per se? And what we do is we use remote sensing techniques. Especially a lot of these are used for looking for shipwrecks, less than looking about for buildings, but we'll go into a little bit of detail about each one of those very briefly. What we can see here is what's called magnetometry. On the right-hand side, the torpedo-shaped object is what's called a magnetometer. What that is it's actually what we call a towfish. It's connected to the ship, and it's towed behind the ship, and it sends out looking for the difference in the Earth's magnetic field from what it's supposed to expect where it currently is located in the world, compared to what magnetic effect might be coming off of a shipwreck, as you can see in the image in the bottom left-hand corner. Why this is an easy way or a good way to find, shipwrecks and things of that nature is, if you think about it, a lot of the shipwrecks from the medieval and then the modern period included iron fasteners, nails, other types of iron equipment, and then you get into the 19th century, after the 1860s or so, you get these steel-hulled or iron-hulled vessels, and all this stuff. When the ship is, wrecked, it stays down there with the rest of the wood and everything. And although maybe the wood might decay or might get eaten by mollusks, such as what we call Teredo nivalis, which is a type of mollusk that survives. And the basic term for this is shipworm. It lives in almost every ocean around the world now. Scientists and biologists are still unsure which natural environment it originated from. Some say the Caribbean, others say the northwestern Atlantic area. Just kind of depends on who you ask, but they love to eat all of that wood. So the wood decays, but the iron stays. And we'll get into talking about what happens to the iron in the saltwater environment as we go through this presentation. But in this case, either way, when the iron is first melted at a high temperature, all of those molecules align with themselves to a certain magnetic north, depending on where in the world it was originally forged. When a shipwreck goes down and has all of that different iron that was possibly forged from different places, it creates its own magnetic miniature field that is completely different from the normal magnetic Earth field that surrounds the Earth in any type of location. So when we use this toefish, we can see basically kind of like a heart monitor blips on a screen that will show us where, that will say, hey, there might be a single iron object or a multi-iron object in this location. And once we collect that data and analyze it, we will take divers out, try and relocate this specific GPS point. Because as we're towing this toefish, you can see that on the image, there's a GPS antenna to try and pinpoint the location of the boat / the toefish itself in order to go back, revisit that target, dive with divers, and figure out whether or not it's a shipwreck or something else that may have been left on the seafloor. Sometimes it's a shipwreck, depending on where you're surveying. Sometimes it could be a washing machine. There's a lot of strange and random things that are iron that are on the seafloor. You never know what you may find. Another tool in the underwater archaeology equipment is side scan sonar. And again, it's put into what looks like a torpedo, a towfish, as I said before, what we call it. And this is again towed behind the boat. But in this case, instead of just looking for a difference in the Earth's magnetic field compared to what it may feel around it, this one sends out acoustic signals. And the acoustic signal is represented on your screen by the two blue sections on the right and left-hand side. What you see in the center is called the nadir, and there's no acoustic signal that is shot directly underneath the towfish, so that's usually blank. But on the right-hand side, you can see like a gray object. And when an acoustic signal is sent out, it will hit something on the seafloor, either the seafloor or something above the seafloor, and will send the reverberation of that signal back to the towfish, and then that will be recorded onto a computer on the boat, and it'll show you a picture of what that looks like. The other thing to take into consideration is because that acoustic signal goes out, hits something, reverberates, then comes back, it doesn't go through the object. And so what you see behind the gray thing on the screen, called the shadow, represents no data that's received. So what does this all look like on our computer screen? It looks something like what you see now. So the very skinny part on the left-hand side of the image is a very long track along some type of seashore where the side scan towfish has sent out an acoustic signal and something reverberated back, and it showed what it looked like on the seafloor. On the right-hand side, what zooms into a section of that long profile of collecting that data, it shows you what looks like a shipwreck. And even there's a small square zoomed in on a small section showing you some of the ribs, if you will, on the framing of what may be an iron shipwreck of some form on the seafloor. On the right-hand side, you can see that dark section has less detail because all of the acoustic signals hit the side closest to the center of that image first, and then reverberate back without collecting the data on the other side. Here's two more examples of that. You can see on the right-hand side is a longer, slender vessel of some form. And on the left-hand side is a B-52 bomber that was found in the Pacific. The right-hand image, the one that's showing you the long, thin vessel of some form, all of those black sections that you see is where no data was collected because the acoustic signal originally hit something closer to the center, which I believe the nadir would probably be on towards the bottom of the image. In this case, it's just rotated on side to show you guys. And so it leaves no data there. However, it still gives archaeologists data because what that means is The black sections are showing you the profiles of something that's above the seafloor. So there's prominent structure that goes from the seafloor into somewhere into the water column. Something that you want to be taking consideration if this is a shallow water wreck and you don't want anyone to drive over it and suddenly hit something that's above the seafloor that's just below the waves of the surface. Or something to take into consideration if this isn't a site that an archaeologist wants to investigate, and we'll go down and take measurements and things, or probably just make sure they don't land on anything when they're trying to investigate the site in the future. Another technique that's similar to side scan is called multi-beam. Here you can see an example of a ship on the surface, and it's got a hull mounted multi-beam, which basically sends out multiple signals, like basically a lot of sonar being sent out onto the seafloor. And all of that is a larger swath that is returned back to the vessel. It's recorded and creates, an elevation map type of material. You can use this as well to record shipwrecks in a more detailed 3D manner than, say, with the side scan. Because with side scan, you're on a lower frequency. You're only sending out one acoustic signal, recording it back. This one, you're doing multiple beams being sent out at once every single time it passes. Multi-beam is a little bit more also changes because this is how oceanographers map the natural seafloor. So they send out these large multi-beams from the hull of a ship, and they record 2-mile swaths of the seafloor or more as they move on an ocean-going ship. The multi-beam can also be organized and tweaked to be more concise and map something that's closer to the surface and don't cover such a large swath area. Because when you're collecting that amount of data in a large swath area like that, shipwrecks in a 2-mile coverage or more could represent a tiny little blip rather than the detail that you see here in this example. Another option is what's called sub-bottom profiling. And sub-bottom profiling is basically similar to multi-beam and side-scan sonar, but you're sending out one strong acoustic signal that is sent to the seafloor. It's such a strong acoustic signal that you can actually hear it click sometimes when you're on an actual ocean vessel when they're using it. Sends it through all of the, into the depths of the ocean, and hopefully it's strong enough that it'll penetrate into the substrate, all the sediment on the bottom of the seafloor, and then reverberate back at a different signal that will be recorded, as what you can see on the right-hand picture showing you the ship with the signal being sent out and then received with buried sediment. And then on the left-hand side is what that visual representation can see when you do sub-bottom profiling. In this case, there is a shipwreck that is laying on the surface, and that's outlined in both images that you can see, but the signal is strong enough that it penetrates past the wreck into the bottom with the sediment surrounding the wreck itself, and you can see the hard substrate, like the bedrock, if you will, or at least some type of hard amount of sediment that comes up as a different layer. This is necessarily something that's more strongly suited to looking for buried wrecks in a confined area that you have a very strong research grasp for where they may be. Otherwise, this is also a technique being used by those archaeologists I mentioned towards the beginning of the presentation, looking for occupation zones by Native Americans first peopling the Americas or other places of early human development, if you will, in the Mediterranean and other places, where because of thousands of years of sediment accumulation or between, some type of burial happening, or it's off the shore now in the Gulf of Mexico, for instance, by several miles, they're looking for some type of telltale signs, usually of like river networks, especially where two river streams might connect together. And that might be a telltale sign of a location where it might be a good camping ground back in the time, when the Native Americans were first trying to colonize the area or settle the area, or just part of their natural hunter and gatherer area of migration. And so when they've done this and they've been able to locate, these campsites because of looking for these river channels that are off of these coasts and finding some type of human either not necessarily human remains, but just some type of human occupation in those areas and some type of artifact, something left behind, even if it's just refuse. So it's another way of using the sub-bottom profiling. A lot of these are easier said than done when something is on the surface on the seafloor, so you can visually see it, but when it's buried, it's a lot more difficult to find these things, which is why the magnetometer makes that easier. The one thing about sub-bottom profiling is you need a more muddy, less compact type of sediment to do this in. If it was a hard clay or a very hard packed sand, the acoustic signal can't really penetrate as well in those type of environments, so it doesn't really give you back as much of a signal. So it also depends on your sediment type in order to find this type of data. So now we've talked about the history, we've talked about how we find archaeological sites underwater that aren't already known. But what do we do when we find one of these things? We record it, possibly excavate. There's different ways to do this. There's different discussions about whether the ethics of doing this. The predominant ethic that's founded by an annex code from UNESCO, part of the UN, and has been adopted by multiple countries, but not all, is, leaving these shipwrecks as they are, what's called in situ preservation, to allow it to reach some type of equilibrium with its environment, the natural environment surrounding it. Because once you disturb a wreck that's reached that type of level of equilibrium, it reopens the process of it degrading, possibly, whether it's because you've exposed some wood to shipworms that might attach themselves and start eating that new exposure of wood, whether it's a coral outgrowth that covers these what are called ballast mounds. It's ballast. Every wooden ship needs a counterweight within it because wood floats. So one of the things they do is counteract that with cargo, but they still need a permanent counteraction for that, which is called ballast. And a lot of the shipwrecks I work with have a lot of rock in the bottom of their holds, just river stone. It's been smooth, but it's a good enough weight to be put there. But when a shipwreck goes down, all that wood is exposed, it gets eaten by the teredo worms, and then what's left is this rock mound, and then it becomes a great staging ground for coral and things to grow. So the best idea is to keep things as they are. But for us to really understand, especially about time period, about places that we don't have a lot of data or knowledge about themselves, because either the historical record doesn't exist or the historical written notes about that period may not equate to what actually happened in real life, we have to do some type of excavation. We just try and do it as minimally as possible. So here is one example of that. This is an archaeological site that's completely buried, and what somebody has decided to do in order to preserve the site for future generations or for future techniques we don't know about now to make better preservation projections or ideas or decision making, is that they will selectively make squares, sometimes selectively by an archaeologist, other times randomly selected, to excavate certain sections of the site to give you some detail. Another way of doing it is to just take one slice of the pie, if you will, by doing trenching. You can see here the same archaeological site. In this case, they've cut a trench through the site, which gives you some information about the site and leaves the rest of it for it to be preserved or to keep intact in that equilibrium we talked about. And then finally, there is more of what you would consider an old-fashioned way of doing it, which is a full, complete excavation of that area. In this case, what you can see is there's a shipwreck here, a small boat of some form. There's a pier that it may have sank next to that was also abandoned in some form with some rocky outcrops to protect the shoreline, and even maybe a structure like a dock house or some type of storage for maybe the boat or for visiting ships of some form or whatever. And so usually what archaeologists like to do now is to try and avoid doing that complete excavation if possible, and want to do more of the selection if needed. But if you're going to do full excavation, you have to have some serious research questions you want to answer when you do that. And at the same time, you want to have a fully prepared, fully funded conservation plan in order to preserve these objects afterwards so that they stay intact and that they're for the public benefit in some form. And so later on, we'll talk a little bit about how to conserve certain types of material. So we talked about those squares and what archaeologists like to do on land and underwater. So it is to use a grid system. Each grid might have a letter and a number to it. It might be some other way of doing it. Here, I'm showing you 3 different ways of doing a grid system with, different types of equipment or different types of tubing, but they're all using it the same. And this is the same type of grid system that a lot of terrestrial archaeologists do, showing that even though this environment is more dynamic, humans aren't naturally breathers of underwater like fish are, and we have to use a lot of equipment to do that. We can maintain the same rigors as an on-land site in order to record that type of thing. Well, how do we actually remove the sediment in order to do this excavation? Does it affect the natural environment around it? Is it destructive, et cetera, et cetera? The truth of the matter is it is destructive. Archaeology as a process is a destructive thing, which is why we try and record and collect as much data as possible when we do it, so that even if we aren't answering a specific research question at that moment, some of the data we collected might be able to answer a different research question in the future that we that are in charge of that site may think of later on, or if there's another researcher in the future, even decades later, who has a different research question they want to address, and they can come back and look at that data to answer their question that may have not been answered originally when we excavate. So we try and collect as much data as possible in that way. 2 ways we do the removal of sediment in a concise and workable manner is using a dredge. And what you see in this screen right now is what's called either an airlift or a water dredge. I'll show the water dredge in a moment, but this airlift is usually often used in shallow water environments. And what that is this is a diver holding a PVC pipe. Attached to the bottom of that pipe is a hose. In this case, attached to an extra scuba tank, but also can be attached, depending on the depth and everything, to some type of air compressor on the surface. Air is pushed through the hose into the pipe, and then it is slowly controlled by a valve. That's what the hand that's not holding the pipe, but the lower hand is probably controlling some type of release valve to allow air to escape. It slowly escapes into the main PVC pipe and then goes up the pipe and exhausts up towards the surface as it expands. When it's doing that, it's creating a suction effect, if you will. It's pulling the water up through it along with the air itself, getting a Venturi effect, and that becomes an underwater vacuum. Same thing with the water dredge you can see in the bottom right-hand side. In this case, you can see 2 water dredgers being operated. The difference between the airlift is instead of pushing air to the bottom of a pipe and then letting the air go up the pipe in order to create a suction, and with the water dredge, you're using a water pump in order to push water through what you see in this image is the blue hoses that go into a 2 connection pipe. The side section goes into the silver pipe in the center and then is exhausted out the back. But as the water is doing that, it also creates a Venturi effect of a suction, so that the yellow hoses that you see the diver in the foreground is holding, it becomes also an underwater vacuum. And this can be very controlled. With the airlift, you could even be a little bit more controlling, because you can control that increase or decrease of the air for when you're removing and gently removing sediment, or need to remove a more amount of sediment at once. Whereas in the dredge is a little bit less controlling, but you have to be, it's from years and years of personal experience using a water dredge, I can guarantee you it's just as easy to control. The other thing to take into consideration when you're doing this type of excavation is once you get to a point where you actually know you're going to be working with, you're past the sediment and you're starting to reach a layer where there's actual artifacts and things, you're not using the dredge directly into that sediment and unfortunately, possibly sucking in artifacts and things of that nature. What you're usually doing is you're holding the dredge with one arm or with one hand, and then you're using your hand to slowly waft in the water to create that, to stir up that sediment. So the sediment starts catching into the dredge itself nearby and sucking up. People use their hands to do this. People use a brush to do this. People have used trowels if you're working in a hard clay environment. It just kind of depends on the situation. But in this case, it's the underwater archaeologist's best friend, regardless if you're working on a shipwreck or a structure underwater or looking for those early inhabitant sites. We all use the same techniques in order to remove that amount of sediment. If for some reason there's an artifact that somehow got sucked up for some reason, I'm showing you two pictures of some decent visibility. There's always a lot of people always work in lower vis environments, and so that could happen. Well, with the airlift, but more, there could be some type of, the airlift could bring all of that water up to the surface and then be somehow pushed onto a screen, possibly. On the other side, with the water dredge, since most of it goes underwater, you can see on the back side of the water dredges, the bottom right-hand side of the image, there's another yellow hose going off onto the right-hand side that gets cut off by the end of the image. Well, on the other back end of that, there is usually what's called like a dredge spoil bag of some form. And so if there's an artifact that somehow goes through the entire hose, it'll be catched by a double meshed bag or some other type of system where the water will go through the screen, but it will catch whatever you may have not been able to see with your eyes because we don't want that to actually happen, but sometimes it does. And then we'll take that bag to the surface and then, use a screen on a boat or on a barge or whatever type of platform, and then go through it by hand and see if we caught anything we may have missed, unfortunately, in the water. But in a nutshell, that's the two techniques that we really use. It's very controlling by hand. It's very easy to use these processes. And you don't really disturb that much necessarily sediment in like a small type of environment like this. So once you uncover something that needs to be recorded, or say you've got a hull structure or some type of building underwater that's already kind of still exposed to the open sea or lake or whatever that you might be working in, we need to do that type of recording and record, and there's different ways to do that. What you see here is what's called a baseline offset. And these are students practicing on land before they go underwater, where we put out a long tape reel along the center line of a ship or a building or something. And then we do 90-degree offset measurements in order to record that structure. Here's an example of this. This is a photo mosaic, which is a collection of multiple photos taken that overlap with each other of a shipwreck. If an archaeologist goes down to record the hull, instead, they would put probably a baseline, which is that tape measure down the center of the ship, and then record offset measurements off of it. And here's an example of that. Here's where they created a baseline, and then you can see in the bottom right-hand side, two red lines coming off that baseline to create baseline offsets. And that's how we build site maps of surviving structure. Another way to do this, if you're doing a little bit more excavation, a little bit more gridding, something that's kind of buried and not less just already exposed, like the previous example, is we use this thing called direct survey method. In this case, you can see a diver who's in a grid, and there's already pre-planned locations of several tape measures. And what they will do is they will take a tape measure distance from all three of those tape measures to get an accurate pinpoint within the grid system of an object that they're digging up. Once they have mapped something out, with the direct survey method or something else, or they want to record a drawing of what everything is like as it is in situ before they start removing it, they might put down a grid like this one. It's a miniature grid inside of a major grid with double strings to create a smaller grid system. And that's what they would do with like underwater graph paper called Mylar. It's basically plastic film that we can write on and then erase if we need to. In this case, he's using a Mylar with a slate. And the double stringing helps you make your accuracy underwater a little bit better because you can make sure your lines are correct, because you want to make sure those two strings overlap with each other. And then finally, if you're dealing with shipwrecks like I am, and they have a curvature to them, which most ships do, they will do what's called offsets. Here, this diver has some type of tape measure that's been leveled and connected to two stakes that have been put into the ground outside of the archaeological area. and then he's just using a rigid ruler of some form, and he's just taking every couple of centimeters or every couple of marks, however he just decides to do it, getting depth measurements in order to create that profile. And finally, another technique that archaeologists have been picking up more and more on with the with the invention of new computer technology is what they call stereophotogrammetry, or photogrammetry for short. And this is kind of like making a 3D model with all of those photomosaic images you saw with the previous image of that shipwreck. In this case, this is an example from one of the software programs where it's showing you that somebody went around a statue, took a bunch of pictures. The computer program uses an algorithm to figure out where those photos were taken in relation to a single object, like multiple pixels and colors within each photo. It's been able to make the 3D model with those still photos in order to create a 3D model that could be either used to show people about the statue, or it could be used to print out with a 3D printer to print it out for some reason if you wanted to. In our case, what we end up doing a lot of times with underwater archaeology is it's one of the greatest new tools we have in our arsenal, because only a small percentage of the world actually dives and visits this underwater world. And so for us to bring it to the public, we can go down, take hundreds upon hundreds of photos if needed, or even smaller amounts depending on if the visibility and your capability of doing so. In this case, this is an image with hundreds of photos that were taken all at once of a Venetian ship off the coast of Croatia. And it shows you that there was surviving hull structure before it was, that was buried and then uncovered. And you can even see in the bottom right, there's all those objects that are next to each other. Those are barrels where everything that was buried was preserved, including contents, but everything above was, eaten away by the marine organisms and the natural environment. So they're like half barrels because of it, type thing. Which, again, this kind of gives us a wonderful image to show people. This is what we see underwater. This is what, if you are unable to dive for some reason, you can still visit this wreck and interact with it. People also put these things into VR headsets. So you can put on a VR headset and pretend that you're swimming like an underwater archaeologist to dive on these things and investigate them on your own and see what we saw when we took these pictures to make these 3D models. And so it's a wonderful tool, not just for us to analyze and look back on after we get back to shore to do our studies, but for the public to really interact and learn more about, these shipwrecks and underwater archaeology. Same process could be used as you saw with that statue on land. It's been used with structures and anything else underwater, as long as you have good visibility and a good camera to take the pictures. Moving forward, I promised talk about some artifact conservation earlier in the presentation. In fact, the director, Tuminello, also asked me to include some of this. So we'll talk about all of these organics that we find and what we do with them, and also with the iron artifacts, what we do with them. What you can see here is what's called a concretion, and this is a bunch of metallic and iron artifacts that were on a shipwreck off the coast of North Carolina, and they have turned into this concrete object together, built with calcium from the sea. When iron doesn't necessarily like to stay iron, it always likes to rust and break down. And especially in seawater, it'll break down even more quickly. But as it breaks down and interacts with the sea environment, creates electrolytic reduction on its own in the natural environment. And as that iron breaks down, it creates basically this calcium cocoon that we call a concretion. In this case, this is an object, like I mentioned, off the coast of North Carolina. But how we understand and try and conserve this object is we do X-rays. Here you can see in this X-ray of the same object what was inside of it. There's some lead shot, a grenade, looks like some type of calipers, a divider. A divider is something like a compass used for navigation on a ship, a cannonball and some lead sheets, and even maybe a rigging hook. The same process happens to iron regardless of the size. How we try and take all these artifacts apart is using what's called a pneumatic air scribe. Basically, it's the same process as a jackhammer or any type of pneumatic device. pressurized air goes through it, and the tip goes back and forth like a jackhammer, and then you slowly can use this to remove each object separately from each other to then undergo what's called electrolysis. Here you can see a cannon on the right-hand side. It is very concreted by the buildup of calcium as iron slowly decided to go into the seawater, if you will. You can see a section of the concretion that was broken off just recently and then put upside down against that tire on the left-hand side, showing you what they look like on the inside of the concretion. Here's another cannon. It's different from the one that you see on the right-hand side. It's currently undergoing that process, but half the water has been removed out of it. How this all happens is the cannon or an iron object is placed into either a sacrificial vat, in this case, this iron vat of some form, or it could be put into any vat and then surrounded by a sacrificial anode of some form, some type of other iron. Lots of people use like some type of wire fencing or some type of other type of hashed material that allows water to flow through it. It's filled with distilled water. That water needs electrolyte. And so a lot of times we'll put sodium hydroxide in there, which the common version that you probably know more of is called lye. You will attach a DC power supply, a direct power supply with the negative attached to the iron artifact, and then the positive will be attached to the sacrificial anode. In this case, you can see here in the back side of the cannon, there's this C-clamp, which is what is the connection for the negative to the DC power supply. And then somewhere on the side of this tank, the positive connection is connected to the tank itself. And then as you slowly turn on the power, you turn on a low power supply, there's an exchange of electrons between the sacrificial anode and the artifact, which is considered the cathode. And what you're doing is you're removing the salts that is collected from the sea and the sodium chlorides out of the object in order to preserve it. Because if you left those in there and you simply took the artifact, such as the cannon on the right-hand picture, removed it, took off the concretion, and then just left it sit out, it's still so full of salts, it will start to crystallize and break down, and the whole object will fall apart. So you really want to go through this electrolysis process in order to conserve it. And then on top of it, once you remove all those sodium chlorides and it's a low enough level, you'll take the object out, you'll boil it in water in order to remove any of that sodium hydroxide that's attached to it. And then you will cover it with tannic acid as a protective layer. Tannic acid is prevents moisture. And then finally, you will immerse it in hot melted microcrystalline wax, which adds another vapor barrier to the object. So whenever you go into a museum and you see any type of iron objects anywhere and they're black, or you go to, say, see a cannon or an iron object at any of your local parks, like a National Park Service park, and they're black, it's because of the tannic acid that creates a protective barrier with the iron after it's removed from that boiling of the water. Wood is a very interesting subject. It is an organic material, obviously. There's also a specialized discipline called dendrochronology, which is the study of tree rings and really study of trees in general. You can use it to study how old a tree is. And if a ship is built out of wood, we use it in underwater archaeology to work with our dendrochronologist specialists and colleagues so to see if they can tell us how old the tree was before it was cut down. It might give us more of an identity or a date for the shipwrecks itself. But there's plenty of things besides shipwrecks: boxes, barrels, crates, anything. A lot of things were made with wood. And so wood is a large part of the conservation process of preserving these things to be put on display in museums. Here on the right-hand side, you see underneath a microscope, a small thin slice of the wood itself, and all of those little holes are basically different cells of the wood. This is a similar image of wood, but this is waterlogged wood, and you can see all the cells are intact, but the internal part of the cells, where all of the life used to be, is missing and gone, because when water is saturated in the sea, if wood is saturated in the sea or underwater for any long period of time, centuries or even less than that, depending on the type of wood, all of the central parts of the cells will leach out and will just dissolve into the water. But the actual, skeleton of each of those cells will stay intact. But the reason the skeleton stays intact is because all of those cells are just replaced with water. If you take the wood out without doing something to protect that wood and it starts drying out, water is sticky in a sense, because when it evaporates, it will slowly pull all the cell walls towards the center of the water droplet. And if you imagine that on a larger scale with the wood, you can watch a wooden object shrink to 4 or 5 times its original size because all of it was filled with water, and the only thing left of the wood was just those cell walls that had just broken down because of the evaporation taking place. So what we like to do to preserve wood is use what's called polyethylene glycol, or PEG for short. You can see 3 different versions: the PEG 400, 600, or 3350. This is molecular weight. And it changes basically the molecular weight of polyethylene glycol. You can see at room temperature at 400, it remains in a liquid state. 600 is kind of so-so. At 3350, it remains more, a more molecule state rather than in a liquid state. But we will use each of these depending on the treatment of the wooden artifact and how it, what its condition is, in order to bulk up all of the inside of those cells. So each cell will have the water be replaced by the PEG. Usually we'll probably use more of 3350 than 400 for this part of this process, because as you can see, once PEG is dry, that 3350 is dry, it will stay in a more solid state. So what we'll do is we'll keep wood in water. We'll pour the PEG in. We want to reach about 20%, 30% consistency of saturation of the wood, and then we can do something what's called freeze drying, or we can do bulk the entire wood up to 100% with PEG. It really just kind of depends on the conservator, the process they want to do, and the actual artifact they're trying to conserve. In this case, what about an entire whole shipwreck? This is the warship Mary Rose, originally built in the early 16th century. It went down in a naval engagement with the French in 1545. It was found again at the end of the 20th century, was raised in the 1980s, and then brought to Portsmouth, which was where it sank. It sank in the bay right outside of the city, and now is in a museum. And for the last several decades, what they've been doing to conserve it is to spray it with PEG. Here you can see an image from the Mary Rose Trust, which is the museum in charge of the actual ship and all of its artifacts that were on board. And this is a gentleman on the top left who's in a hazmat suit, and he's checking the ship to make sure everything's going okay. And they're constantly spraying the PEG I talked about earlier for the last 20 years, and then air drying it by putting all these, on the right-hand side, you can see all these black lines. These are air ducts that are trying to dry out the ship. With smaller amounts of wood, they can freeze dry it. You can see here in the bottom left, they've inundated this wood with some PEG in a vat, and then afterwards they freeze dry it in that container on the right-hand side. What is freeze drying though? What you mean by freeze drying is the object is impregnated with a certain level of PEG, and then we put it in a vacuum freeze dryer, because what you're doing is you're trying to remove all of the water, but you're trying to remove the water without it going from a solid to a water state and then evaporating. You're trying to skip that water state. You're trying to go from freezing it and then trying to dry it out slowly in a vacuum, so that what's called sublimation, which removes that water without it ever getting to the water state, so that it could, get wet, start drying, and start pulling the cells and destroying the object from within, if you will. So by freeze drying it, you skip all of that, and you remove the water, and what's left is just the PEG that's solidified within the object to keep it intact, so you can put it on display. And here is the final product of the Mary Rose, for instance. I know this is a little bit extreme, if you will, because this is such a large ship and they never took it apart, but this is just a very large example of that same process, as well as what I just described before with the previous image of the smaller pieces that were able to sit in a vat rather than just get sprayed for 20 years. And so far, luckily, they've been doing so-so with this. For other objects that you might find that are organic, such as leather in this case, it will go through a very similar process. Here you can see the images were in some type of controlled environment. The yellow things on the right-hand side are humidity. They monitor the humidity within a controlled space. They bulk them up probably in some type of container beforehand. They freeze them in a top horizontal freezer you can see on the left-hand side. And then above is a smaller freeze dryer where they did the same process. Here's another example of that. Before treatment, above is some type of leather sole, and then the bottom is them drying it out, trying to preserve the object. And you can see the color kind of change because of all that water being removed from it. I wish there was a little bit more of a detail I can go into with the conservation process, but the thing about conservation, especially with underwater objects, is it's kind of its own science and art at the same time, because it always is going to depend on what you perceive. What is the object? Is the object made of one thing? Is it a composite thing? Does the object need to be taken apart? And can it be taken apart? Is it individual pieces that can be treated separately, or does it have to be treated together because taking apart might damage or ruin or destroy the object? It really just kind of depends. But for the most part, what I showed to you today, talking about the iron artifacts, is really the control for most metallic objects. You can do the same electrolysis for copper, for bronze, and just goes through some slightly different steps for the final steps at the end. But all of it goes through the same type of electrolysis process. And when it comes to organics, there are other processes out there in order to do it. There's entire books about those type of things. But this seems to be one of the more ideal processes for both wood and for other types of organics that might be found in a waterlogged environment, which is that bulking of the cells, because there's nothing left of this except for the cell like skeletal structure, and then trying to remove that water in a way that it won't allow water to be wet and evaporate and then destroy and shrink the object, or destroy the object by shrinking type thing. And just last but not least, we do find in underwater environments still, just like any other type of archaeological environments, linens or other types of yarn or other types of animal hair, and that goes through its own process of washing. Here you can see one of these examples was found very dirty in a muddy environment. The mud probably acted as an anaerobic environment, which means a lack of oxygen, which preserved it better than if it was open and oxygenated the entire time. It probably wouldn't have been preserved. And they're just basically kind of doing a very controlled washing. They're using a controlled amount of distilled water probably. There's a little brush that they're using in very tiny circular motions. And then as they slowly wash out all of that dirt and mud, they start revealing on the right-hand side, that dye and that color, that vibrant color that was originally part of that object, whatever it may have been originally, after it's been, gone through that type of process. Finally, just to kind of round out all of this, talking about underwater archaeology, where it came from, what we do, let's talk a little bit about a couple examples that are more closer to home, say in your backyard, if you will, because Benedictine University is in Lisle, but it is in the greater Chicago area, and Chicago is against a major body of water known as Lake Michigan, and is part of the Great Lakes system. And there's hundreds upon thousands of shipwrecks across all of the Great Lakes. So talking about the Great Lakes also we need to address one of the big groups in the room that concern themselves with shipwrecks, which is the National Oceanographic and Atmospheric Administration as part of the U.S. Department of Commerce. Back in the 60s and 70s, there was legislation put in place to protect a lot of things in natural environment and also underwater environments, on land and under the sea. One of the things that was enacted was the National Marine Sanctuaries Act. Ironically, although it's called the National Marine Sanctuaries and its focus is creating underwater preserves for the protection of the natural world and the fish and any types of marine organisms, the first enacted sanctuary, if you will, is actually a shipwreck called the USS Monitor. That is the famous one that fought the Merrimack, or the Confederate ironclad, if you will, at the Battle of Hampton Roads. Unfortunately, when the Monitor was being towed by another vessel to come back down south during the Civil War, it was lost off the coasts of the Carolinas, and it was found again. In order to protect it, they used the National Marine Sanctuary Act to conserve it. So you can see in this map that the National Marine Sanctuaries are all across the continental United States and also in its territories and other places in the Pacific as well, including Hawaii, and a lot of the smaller islands as part of the volcanic chain of Hawaii are part of a national monument, as you can see here. Some of the more recent or newer national marine sanctuaries includes Thunder Bay National Marine Sanctuary, which is in northern Michigan. And you can see here, this is the northern part of Michigan covering this area. Everything in light blue was the original extent of the marine sanctuary. What you see in the dark blue is more in the last few years is now the coverage and protection of the marine sanctuary itself. But this marine sanctuary, just like the USS Monitor Sanctuary, is not only preserving some of the natural fish in that area because of control of certain fishing, but it mainly exists because this is a shipwreck alley for a lot of shipping that went back and forth between all of the different Great Lakes over the last 200 years. One example of that is the Monohadset in 1907. On a night of November 23rd, 1907, the Monohadset was hiding behind a local island in Thunder Bay, and it was avoiding gale force winds sweeping across Lake Huron at the time. But unfortunately, shortly after 10 p.m., there was alarms that sounded, and crew members reported a fire. There was apparently an oil lantern that tipped over, and then the blaze quickly spread. It was the crew's worst nightmare, but luckily, they were able to get off and survive, the crew itself, but the ship itself was carrying 900 tons of flammable coal. So a lot of the hull was quickly burned. Luckily, the small island that they were hiding behind had a life-saving station at that point, and so all the crew was able to survive. They were able to get off of the shipwreck, but they fortunately couldn't save their ship at that point. It's become a very popular attraction because it is only in 18 feet of water. The ship was originally 160 feet long and 30 feet wide. It was basically considered a wooden steam barge at this point. It was originally launched in 1872, so it had a decent life before it was actually lost, unfortunately, in this wrecking event. Here you can see the previous picture, and this picture is showing you the stern, or the very back end or rear end of the vessel, if you will. And it's showing you the prop shaft, and the prop itself is still in place as it was when the ship went down, over 100 years ago at this point. And there's a little diver right there. So clearly, if you're interested in diving and want to go up to northern Michigan, you can visit this shipwreck along with many others in this area. In fact, there is something called Thunder Marine Sanctuary Museum in Alpena, Michigan, that I would highly recommend going to and visiting, because the museum has a lot of wonderful artifacts, not only from the Monohadset, but from other shipwrecks in the area, and really tells you a story. It's very interactive. Especially if you have smaller kids, there's a lot of things you can learn about the sanctuary itself and the shipwrecks and all of the people who used to sail and operate along the Great Lakes. Here's another vision of the Monohadset. This one, the divers you can see on the right-hand side is floating above what's called the boiler/firebox. The bottom section of that, the whole thing is on its side, but the bottom section would be where the flues are for putting the fire and catching the ash. And then the upper section, the more rounded cylinder, is where the water would be to be turned into steam in order to be a steamship to rotate the shaft and the prop that you can see in the background. One of the most recent sanctuaries to ever be established is the Wisconsin Sanctuary, that's located here, the Wisconsin Shipwreck Coast National Marine Sanctuary. It was just enacted earlier this year. And this is a section that is showing you all of the known shipwrecks listed in what's known as the National Register of Historic Places, and also possibly potential wrecks that they may have not been able to locate yet, but believe these are the locations or in these areas that they may have went down. And you can again see a more visual reference of a lot of shipwrecks in Lake Michigan off the coast of Wisconsin now that are going to be protected and part of the local museums and whatnot. The side thing to note is that these national marine sanctuaries aren't just randomly enacted by Congress or anything like that. The local populace such as in Sheboygan or Port Washington that you see in this map, have to be willingly want these things in their backyard. And so there's a long process, over a decade of feedback and interaction with the public before this sanctuary was actually enacted. It's not something that just happens overnight. You have to have a lot of local support for these things because the locals want it there. And also it can bring what's called museum tourism and revenue for people who go and visit, either to dive on the wrecks in a controlled and proper manner, because they welcome that with local dive shops. You take pictures, leave only bubbles, or on the other side of that, if there's any artifacts in a local museum for tourism and for culture and to bring people to come visit these places. The one shipwreck I'll talk about from this is one of the oldest ones in this new sanctuary, called Home, which was, let's see here, it was originally built in 1843. It was built in the Blackwater River in Ohio. The owners were from Chicago, so it's after it was built and put into the Great Lakes. Its home port technically was Chicago. The owners themselves were known as abolitionists, and so there is some speculation that the home might have been part of the Underground Railroad. It was never, there was never a report of them finding any type of escaped African slaves on there, but the fact that the owners were well-known abolitionists and the people who would hire the home were known abolitionists, there is assumption that this ship was part of the Underground Railroad network at the time, to get people probably into Canada, or at least into other safe places in the North before and the Civil War. Unfortunately, on October 16th, 1858, while I was carrying a cargo of merchandise, wood, and cedar posts in Manitowoc, it was going to Chicago, but 4 in the morning, the home collided with the schooner William Fisk in some type of dense fog southeast outside of Manitowoc, and the collision led to the home's side and toppled her mast. The William Fisk, for some strange reason, was left undamaged, but the captain White, who was the captain of Home, and the crew were able to get off of the home that was sinking and was able to board William Fisk after the collision. So unfortunately, that's the reason why we have this shipwreck in this bay. But luckily, it is a pretty wreck. Here again, you can see another example of photogrammetry at work that we talked about earlier. In this case, hundreds of photos were stitched together, and you see a bunch of tiny little dots. Each one of those is a little pixel collected from looking at all of those photos. And what I just mentioned earlier about the final voyage, you can see how the mast had fallen over and sank with the ship. Most of it's still intact, and it's definitely a great diving destination in Wisconsin. But Dr. Bendig, you might be asking, what about a closer wreck to home? Well, don't worry, I've got that covered for you. So, outside in the south side of Chicago, along Lakeshore Drive, in this place called Morgan Shoal. Morgan Shoal was a shallow area that was developed millions of years ago by the glaciers on the North American continent, but it became a shallow area that not everyone was able to avoid. So in this case, there was a package steamer known as the Silver Spring, which was originally, it was a 109-foot long wooden steamship that was built in 1894. Originally, it was known and named the Bloomer Girl, and then renamed later on by a different owner to Silver Spring. Her home port was Chicago, and most of her life she ferried passengers up and down Lake Michigan's southern shoreline until 1914. So in 1914, she was on her way to pick up about 200 University of Chicago students to take them to a tour of the Gary Steel Mills. Unfortunately, she never made the whole voyage because what happened was she misplaced, didn't understand where the shoals were, and got stuck on the shoals. They tried to dislodge her, and they were unable to, and so it just became an entire wreck. And here you can see, very similar to the Mount Handset, the fire and boiler machine, the iron still intact on the bottom. Here you can also see the prop and the propeller shaft itself are still intact also on the bottom of this area. And then at low tides, you can actually see part of it sticking up above the Lake Michigan, and in this photo, they've angled it in just the right way. You can see a little bit of downtown Chicago in the background. So if you're ever interested in seeing a shipwreck up close and right in your backyard, you can definitely just go down to downtown Chicago and walk that Lakeshore Drive area and be able to see it. There's a lot of people also during the summer who go out and snorkel and look at it. It's a little bit of a destination for those who know about it. The one thing I will say before I conclude this presentation, looking back at these ships in particular in the Great Lakes, is a lot of them are wooden vessels with iron in them, or could be iron vessels. There's a lot of other iron vessels as well. But the difference between the saltwater, for somebody who may have this question, is that the marine organisms that love to eat wood only survive in saltwater. So in freshwater environments, these wooden wrecks in the Great Lakes sit very proud and pretty on the bottom, still as they were when they went down, either hundreds or longer years ago, because freshwater, they don't deteriorate as they do in saltwater, and there's no organisms in the freshwater that eat the woods as such. But there is a growing concern with mussels called quagga and zebra mussels that were unfortunately invasive species in the Great Lakes that have been from water dumping of vessels that go back and forth out into the Great Lakes and then into the St. Lawrence River and then into the Atlantic. And these vessels, and unfortunately, these quagga and zebra mussels, they don't eat wood, but they grow on raised structures underwater in the Great Lakes. And there's a fear that they're slowly going from Lake Erie and Lake Ontario, going west and slowly growing, and it's these generations by generations of mussels that are growing on these shipwrecks, and the weight of all of that growth is just tearing them apart. So it's one of the dangers of these shipwrecks nowadays, of trying to preserve them and record as much as possible for especially these wrecks in Lake Huron and Lake Michigan and Lake Superior that are still more intact and haven't had that much growth on them. Whereas fortunately with the Lake Erie and Lake Ontario shipwrecks, it's night and day looking at pictures from the 1980s into the early 2000s of the amount of growth that's on them. So just for those who may have been curious understanding why there's suddenly intact wooden shipwrecks on the bottom of Great Lakes, but not so much in the Mediterranean or any other major oceans in the world. That's why. I'd just like to end this presentation by thanking again Director Carly Tuminello for allowing me to talk to you guys today about underwater archaeology and how the humans have interacted with the natural underwater world for hundreds if not thousands of years, and how my discipline has been going out there for decades now, trying to go out and understand humans' connections with the oceans around us.